Imagine you are sitting in your living room, scrolling through your phone, or maybe you're outside enjoying a bright, warm afternoon. Everything feels permanent. The sun is a constant, a golden ball of fire that has been there for 4.5 billion years and will be there for 5 billion more. But suddenly, in the blink of an eye, the sun just vanishes. Not an eclipse, not a cloud passing over, but a total, absolute disappearance. What do you see? Surprisingly, for the first 8 minutes and 20 seconds, you see absolutely nothing different. You'd still feel the warmth on your skin. You'd still see the sunlight bouncing off the trees. Why? Because light doesn't travel instantly. It moves at about 300,000 kilometers per second, and at the distance we are from the sun, it takes over 8 minutes for those last photons to reach your eyes. But once that final wave of light passes Earth, the world doesn't just get dark, it gets complicated. In an instant, the very laws of physics that keep our planet in place are shattered, and our journey into the infinite, freezing ink of interstellar space begins. The first thing you'd notice after those 8 minutes is the darkness. It wouldn't be like a normal night where the moon and stars provide a soft glow. Because the moon doesn't produce its own light, it reflects the sun. The moment the sun's light stops hitting the moon, it would vanish from the sky as well. The planets would wink out one by one as the last of the sun's rays bounced off them and headed toward us. The only things left in the sky would be the distant stars, dots of light trillions of miles away that do nothing to illuminate the ground beneath your feet. On the side of the Earth facing away from the sun, people wouldn't even know anything had happened until they tried to look at the moon or until the news started breaking. But for those on the day side, it would be the most terrifying transition in human history. One second it's noon, and the next it's a darkness deeper than any cave on Earth. But darkness is actually the least of our worries. There is a much bigger problem, and it travels at the same speed as light. Gravity. According to Einstein's general relativity, gravity isn't instantaneous. It travels in waves at the speed of light. This means at the exact moment the sky goes dark, the gravitational tether holding Earth in its orbit would also snap. We wouldn't feel a jolt or a vibration. Instead, the Earth would simply stop moving in a circle and begin traveling in a perfectly straight line at its current orbital velocity of 30 kilometers per second. We would become a rogue planet, a cosmic wanderer flying through the void. Every other planet, moon, and asteroid in the solar system would do the same. Jupiter, Saturn, Mars, they would all go flying off in different directions like marbles released from a spinning plate. The power grids would be under immense strain as everyone turned on every light they owned. But surprisingly, the temperature wouldn't drop to freezing immediately. The Earth is a massive thermal reservoir. Our atmosphere and our oceans hold on to a tremendous amount of heat. If you've ever walked on a sidewalk after the sun goes down, you know the ground stays warm for a while. On a global scale, it would take a few days for the average temperature to drop significantly. However, within 24 hours, the average global temperature would start to fall toward freezing. In some places it would happen faster, but the sheer mass of the Earth would prevent an instant deep freeze. By the end of the first week, the average global temperature would be around 0 degrees Celsius, or 32 degrees Fahrenheit. For many parts of the world, this is just a standard winter, but for the tropical regions, it would be a total catastrophe. Plants would be the first to suffer. Without the sun, photosynthesis stops instantly. Most small plants would begin to wither within days as they run out of energy. The oxygen we breathe wouldn't run out, though. Earth's atmosphere contains enough oxygen to sustain all life for thousands of years, even if all the plants disappeared tomorrow. The real issue is the cold and the food chain. With the plants unable to create energy, the animals that eat them would struggle, and the ripple effect would climb all the way to the top. 1 month into this new reality, the Earth would be a very different place. The average temperature would have dropped to minus 20 degrees Celsius. The oceans would begin to freeze at the surface, especially near the poles. But here's an interesting twist. Water is a great insulator. As the top layer of the oceans freezes into ice, it actually creates a protective barrier for the liquid water below. This means the deep oceans would stay liquid for hundreds of thousands of years, heated from below by the Earth's core. Life around hydrothermal vents, those volcanic openings on the seafloor, wouldn't even know the sun was gone. To them, the surface world has always been a myth anyway. They rely on chemical energy from the Earth's interior, not sunlight. So, in a weird way, The engine of life on Earth would continue at the bottom of the sea even if the surface turned into a frozen wasteland. For humans, the only way to survive beyond the first few months would be to move. We would need to head toward geothermally active regions. Think of places like Iceland or Yellowstone. We would need to build massive underground bunkers heated by the Earth's natural internal warmth. Since the surface would eventually drop to minus 100 degrees Celsius within a year, living above ground would be impossible. We would have to create giant indoor farms using artificial lights fueled by nuclear or geothermal power. It would be a total shift in our civilization. We would no longer be a species of the sun. We would be a species of the heat, clinging to the warmth of our planet's molten heart. By the end of the first year, the Earth would look like a giant dark version of Pluto. The oceans would be covered in a thick crust of ice, though, as we said, liquid water would still exist deep below. The atmosphere itself would eventually start to change. As the temperature continued to plummet, the gases in our air would eventually reach their freezing points. First, the water vapor would fall as snow. Then, eventually, the carbon dioxide would freeze and fall. Much later, even the oxygen and nitrogen would liquefy and rain down, eventually freezing into a layer of atmospheric ice on the surface. If this happened, the Earth would lose its protective blanket, and any survivors would be exposed to the full, unfiltered radiation of deep space. But let's think about where the Earth is actually going. We are traveling at 30 kilometers per second. That sounds fast, but space is unimaginably huge. At that speed, it would take us thousands of years to even reach the distance of the nearest star, Proxima Centauri. And the chances of us bumping into another star or being captured by another sun's gravity are incredibly slim. Most of space is just empty nothingness. The Earth would likely drift through the dark of the Milky Way for billions of years, a silent, frozen tomb of a once vibrant world. However, there is a silver lining to this cosmic journey. Because the Earth is now a rogue planet, it is no longer bound by the sun's eventual transition into a red giant. In 5 billion years, when the sun would have normally expanded and pulled the Earth into its fiery outer layers, the rogue Earth would be far, far away. We would have escaped the sun's final act. If humans, or whatever we evolve into, can manage to survive in these geothermal outposts, the Earth could technically last much longer as a frozen wanderer than it would have as a satellite of the sun. It's also interesting to consider what would happen to the other planets. Jupiter, with its massive gravity, would continue to hold on to its 60-plus moons for a while, but they would eventually become a wandering system of their own. If the sun disappeared, the entire neighborhood would be evicted. The solar system is a delicate dance, and without the lead dancer, the theater goes dark and everyone leaves. This thought experiment highlights just how much we owe to that one star. Every bit of food you eat is just stored sunlight. Every bit of wind that blows or rain that falls is driven by the sun's energy. We are, in every sense of the word, children of the sun. Could we ever replace the sun? Not with our current technology. Even if we used every nuclear weapon on the planet to try to heat things up, it would be like trying to heat an ocean with a single match. The scale of the sun's energy output is so vast that even a tiny fraction of it is more than our entire civilization uses in a year. The only hope for such a cold future would be a massive leap in fusion technology, essentially building our own miniature suns in labs to keep our cities alive. So, when you look at the sun tomorrow, don't just see a bright light. See it as our anchor, our heater, and our life giver. If it vanished, we would be launched into the most incredible, terrifying, and lonely journey any planet has ever taken. We would have 8 minutes of peace and then a lifetime of fighting for every degree of warmth. It's a reminder of how fragile our place in the universe is and how much we depend on the cosmic coincidences that keep our world spinning. But what about the long term? If Earth is drifting through the galaxy, could it eventually find a new home? It's a possibility, however slim. The Milky Way has hundreds of billions of stars. As the Earth wanders, there is a mathematical chance that it could pass through the gravitational field of another star. If the angle and the speed were just right, Earth could be captured into a new orbit. We would have a new sun. The ice on the oceans would melt, the frozen atmosphere would evaporate back into a gas, and the planet would thaw. This process would take millions of years of travel, but the Earth is rugged. Microbes living deep in the crust or near those hydrothermal vents could survive the long journey. They would be ready to recolonize the surface once the warmth returned. In that sense, the Earth could be like a seed, drifting through the galactic wind. waiting for a new place to bloom. This scenario also makes us think about rogue planets that already exist. Scientists believe there are billions of planets floating in the dark between the stars, ejected from their own solar systems long ago. Some estimates suggest there are more rogue planets in the Milky Way than there are stars. Could some of them have life? Could they have civilizations living deep beneath the ice, powered by their planet's internal heat? We are looking for life on planets orbiting stars, but maybe we should be looking at the wanderers too. The disappearance of the sun would make us one of them, joining a vast, silent fleet of worlds traveling through the dark. If this happened today, the social and psychological impact would be just as intense as the physical ones. Imagine the panic, but then imagine the incredible unity that might emerge as our species tried to survive. We would have to put aside every conflict to figure out how to dig into the ground and build a future. We would become miners of our own world, looking for coal, oil, and geothermal pockets just to stay alive. The surface would become a legend, a place our ancestors used to live in the before times. We would tell stories of the blue sky and the golden light to children who only know the glow of LEDs and the hum of geothermal vents. And yet, there is something poetic about the idea of the Earth traveling the stars. For billions of years, we have been stuck in the same loop, orbiting the same star. If the sun vanished, we would finally see the rest of the galaxy up close. We would sail past nebulae, watch the birth of new stars from the darkness, and witness the grand scale of the Milky Way from a front row seat. It would be a journey of billions of years, a slow-motion voyage across the cosmic ocean. The disappearance of the sun is a terrifying what-if, but it forces us to appreciate the stability we often take for granted. Gravity and light are the threads that weave our reality together. Without them, we are just a rock in a very big, very cold room. But we are a special rock. We have oceans, we have heat, and we have the will to survive. Even in the deepest dark, the Earth would still have its internal fire, and humanity would still have its spark of curiosity. As the Earth moved further into the void, the constellations we know would begin to drift and change. The Big Dipper and Orion would warp and disappear as our perspective shifted. We would see new stars, and maybe we would even witness a supernova from the best vantage point in the galaxy. The Earth wouldn't just be a victim of a cosmic accident. It would be a witness to the universe. Eventually, the Earth might even outlast the stars themselves. In the far, far future, stars will begin to run out of fuel and go out. But a rogue planet, cooled to near absolute zero and shielded by a thick layer of nitrogen ice, could potentially coast through the void for trillions of years. We would be a time capsule, carrying the remains of a billion years of biology and chemistry through the era of darkness in the late universe. It's fascinating to think that the same processes that make the sun vanish in our minds, the laws of physics and gravity, are the same ones that make our lives possible right now. The sun is a magnificent engine, turning 4 million tons of matter into energy every single second. It is a massive, controlled nuclear explosion that provides just enough warmth to keep our water liquid and our air breathable. We exist at the perfect distance, in the perfect conditions, at the perfect time. If we ever find a way to live on a rogue planet, we would have truly mastered our environment. We would no longer be dependent on the mercy of a star. We would be a truly independent civilization, powered by the core of our own world. It is the ultimate test of resilience. The Earth's core is almost as hot as the surface of the sun. That heat is caused by the decay of radioactive elements and the leftover energy from the planet's formation. It is a battery that has been running for billions of years, and it is our ultimate backup plan. So, while the sun disappearing would be a tragedy on a scale we can't even describe, it wouldn't necessarily be the end of the Earth's story. It would be a new, darker, and much longer chapter. It would be the transition from a planet that belongs to a star to a planet that belongs to the galaxy. We would be free from the sun's gravity, but at the cost of its light. It's a trade-off that would change everything we know about being alive. The next time you're outside and you feel that warmth on your face, remember that it's a gift that takes 8 minutes to arrive. It's a gift that keeps our oceans from turning into solid blocks of ice and our air from falling as snow. It's a gift that makes everything from the smallest blade of grass to the tallest skyscraper possible. The sun is our star, our guardian, and our constant. And while we can imagine a world without it, we should be very, very glad that we don't have to live in one. Think about the sheer silence of a world without the sun. No wind, because wind is caused by the sun heating the atmosphere unevenly. No waves, except for those caused by the moon's gravity as it slowly drifts away. No birds, no insects, just the quiet hum of the Earth's inner workings. It would be a world of total stillness. For those living underground, the silence would be even more profound. You would be separated from the surface by miles of ice and rock, living in a self-contained bubble of light and warmth. This thought experiment also helps us understand the importance of energy diversity. If we were solely dependent on solar power, a disappearance of the sun would be the immediate end for us. But because we have nuclear, geothermal, and chemical energy, we have a fighting chance. It's a lesson in preparedness on a cosmic scale. Diversity isn't just a social value, it's a survival strategy for a species living in an unpredictable universe. As the Earth drifts, we would also have to deal with the loss of our celestial navigation. We've used the sun and the stars to find our way for thousands of years. In the dark, we would have to rely entirely on inertial sensors and radio astronomy. We would have to map our path through the dark using the faint signals of distant pulsars, like cosmic lighthouses. Our map of the world would be replaced by a map of the void. The journey of a rogue Earth is the ultimate road trip. No destination, no schedule, just a straight line into the unknown. Along the way, we might see things no human has ever seen before. We might pass through a cloud of interstellar gas that glows with the light of hidden stars. We might see the wreckage of other solar systems that didn't survive their sun's demise. We would be travelers in the truest sense of the word. In many ways, our current life on Earth is like living in a very small town. We know our neighbors, the sun and the moon, and we have our routine of seasons and days. The sun disappearing would be like the town being demolished and us being forced to become nomads on a global scale. It would be a hard life, a cold life, but it would be life nonetheless. And that is the most incredible part of the whole scenario. Life is stubborn. It finds a way in the cracks of rocks, in the depths of oceans, and maybe, just maybe, in the heart of a frozen rogue planet. So, as we imagine the sun winking out, let's not just focus on the darkness. Let's focus on the light we would have to create for ourselves. Let's focus on the heat we would have to find in our own planet. And let's focus on the incredible journey that would follow. We are a part of a vast, mysterious universe. And whether we are orbiting a star or wandering the dark, we have the curiosity and the strength to keep moving forward. The sun is everything to us right now. But even without it, the Earth would still be our home, and we would still be its keepers. The sun's disappearance would be the ultimate reset button. Everything we've built, every bit of our history, is tied to the cycles of the sun. But the core of the human spirit isn't tied to a star. It's tied to the desire to know what's next. Even in -200-degree weather, even in a world where the atmosphere has frozen to the ground, we would still be looking for ways to see more, to learn more, and to survive longer. We are a species of explorers, and the infinite dark of interstellar space would be the final frontier. So, enjoy the sunshine today. It is a rare and precious thing in a universe that is mostly cold and dark. But also, take a moment to think about the incredible world beneath your feet. It's warm, it's solid, and it's capable of carrying us through the greatest journey anyone could ever imagine. In the end, the sun disappearing is just a story, but it's a story that tells us exactly who we are and what we are capable of. It tells us that we are precious, that our planet is resilient, and that even in the face of total darkness, we wouldn't just give up. We would keep the home fires burning deep in the earth for as long as we possibly could. And that, more than anything else, is the true power of life. We don't just exist because the sun allows us to. We exist because we have the drive to keep existing, no matter what happens in the sky. The universe is a playground of possibilities, and this is just one of them. We are lucky to have our sun, but we are also lucky to have our brilliant, resourceful minds. Together, they have built a civilization that can even contemplate such a massive change. We are small, yes. Our star is just one of many. But our ability to understand these things and to plan for them is what makes us part of the cosmic story. And that is a story that doesn't end when the lights go out. It just gets more interesting.